Good day, everyone. How are you today? My name is Irene Joy Vivermilo, your Mathematics 10 teacher, and I am here today to help you in developing your logical and critical thinking skills. Is your module ready? How about your pen and paper? Great! Let's begin a fun and exciting lesson for today.
Mathematics 10, Quarter 1, Module 2 with the lesson Illustrating an Arithmetic Sequence.
For this lesson, you are going to learn number 1, define an arithmetic sequence. Number 2, illustrate an arithmetic sequence. And number 3, solves problem involving arithmetic sequence. In the previous module, you have learned that a sequence is an arrangement of objects, numbers, or even figures which follows a certain pattern. Also, you have learned about the processes in finding patterns of any sequence. Try to look at the sequences. Can you see a specific pattern that they follow? Now, let's try to give emphasis on the differences you observe as we proceed with this module. Now, try to look at the first pattern. 2, 4, 6, and 8. What pattern can you observe? Very good! A term is obtained by adding 2 to the preceding term. How about the second sequence? 3, 6, 12, 24. What pattern can you observe in the second sequence? Very good! A term is obtained by multiplying 2 to the preceding term. How about the third example? 5, 10, 15, 20. What pattern can you observe in the sequence? Very good! A term is obtained by adding 5 to the preceding term. Now, try to observe the following sequences. Can you give the next two terms of the above sequences? Great! Look at the first sequence. 4, 7, 10, 13. What could be the next two terms? Very good! If you get 16 and 19 in item number 1, then you are correct. But how did you get those terms? Notice that a constant number 3 is added to the preceding term to get the next term. For example, 4 plus 3 is equal to 7. 7 plus 3 is 10. 10 plus 3 is 13. 13 plus 3 is 16. And lastly, 16 plus 3 is 19. How about in item number 2? Can you get the next two terms? Great! The answers are 53 and 58. But how did you get those numbers? Very good! Because 5 is added to the preceding term to get the next term. 33 plus 5 is equal to 38. 38 plus 5 is 43. 43 plus 5 is 48. And 48 plus 5 is equal to 53. 53 plus 5 is equal to 58. For item number 3, if negative 4 is added to the preceding terms, then what are the next two terms? Very good! These are negative 18 and negative 22. How about in item number 4? 92 and 90 are the last two terms. Why do you think so? Very good! Because negative 2 is added to the preceding term to get the next term. And lastly, for item number 5, what are the last two terms? Very good! 2 and 1/2 and 3 are the missing terms. But why? Very good again! Because positive 1/2 is added to the preceding term to get the next term. Now, notice that to get the next term in each of the sequences, a constant or a common number is added to the preceding term or the number before it. The constant number being added is called the common difference. And we represent it as D. To find the common difference, D, you can simply subtract the second term a sub 2 by the first term a sub 1. Or it can be written as a sub 2 minus a sub 1. Or the third term a sub 3 by the second term a sub 2. Or we can write it as a sub 3 minus a sub 2. Or the fourth term a sub 4 by the third term a sub 3. Or we can write it as a sub 4 minus a sub 3. In general, a term can be written as a sub n. It is subtracted by its preceding term written as a sub n minus 1. Now, the formula for finding the common difference is D is equal to a sub n minus a sub n minus 1. Now, all these sequences are called arithmetic sequences. But what is arithmetic sequences? Arithmetic sequence is a sequence in which term after the first term is formed by adding a fixed number to the preceding term, and it is called arithmetic sequence. The fixed number or constant is called the common difference, denoted by D. Now, for our first example, determine if the sequence is arithmetic or not. If it is, find the common difference in the next three terms of the sequence: negative 4, 3, 10, and 17. Now, is this sequence arithmetic? Yes or no? To find out if the sequence is arithmetic, there must be a common difference between any two consecutive terms in the sequence. Now, let's check.
To find out if the sequence is arithmetic, there must be a common difference between any two consecutive terms in the sequence. For this sequence, let the first term negative 4 be a sub 1, let the second term 3 be a sub 2, let the third term 10 be a sub 3, let the fourth term 17 be a sub 4, and for the last three terms, let them be a sub 5, a sub 6, and a sub 7. Now, let us check whether the consecutive terms have a common difference. Let's start with a sub 2 and a sub 1. Let us subtract a sub 1 from a sub 2. Substitute the value of a sub 2, which is 3, and substitute the value of a sub 1, which is negative 4. Now, perform the indicated operation. 3 minus negative 4. This will become 3 plus 4. Simplify. 3 plus 4 is equal to 7. For the next pair of consecutive terms, a sub 3 minus a sub 2. Substitute the value of a sub 3, which is 10, minus the value of a sub 2, which is 3. Perform the indicated operation. 10 minus 3 is equal to 7. And lastly, for the set of consecutive terms, subtract a sub 3 from a sub 4. Let a sub 4 be equal to 17 minus the value of a sub 3, which is 10. Perform the indicated operation. 17 minus 10 is equal to 7. Because there is a common difference between the consecutive terms, which is 7, the sequence is arithmetic. Since the common difference is 7, the next 3 terms can be obtained by adding 7 to the preceding term. Now, let us try to find the value of the 5th term, or the a sub 5. A sub 5 is equal to a sub 4, which is the preceding term, plus the common difference, which is 7. Now, let us substitute the value of a sub 4, which is 17, then copy plus 7. Perform the indicated operation. 17 plus 7 is equal to 24. Next, let's get the value of the 6th term, or a sub 6. We can get this by adding the common difference, which is 7, to the preceding term, which is a sub 5. We can write this as a sub 6 is equal to a sub 5 plus the common difference, 7. Substitute the value of a sub 5, which is 24, then copy 7. Simplify or perform the indicated operation. 24 plus 7 is equal to 31. Lastly, for the 7th term, or a sub 7, we can obtain this by adding a sub 6 plus the common difference, which is 7. Substitute the value of a sub 6, which is 31, then copy plus 7. Perform the indicated operation. 31 plus 7 is equal to 38. Thus, the common difference is 7, and the next 3 terms are 24, 31, and 38.
Now, for example number 2, write the first 5 terms of the arithmetic sequence with 5 as the first term and with a common difference of -2.
For example number 2, write the first 5 terms of the arithmetic sequence with 5 as the first term and with a common difference of -2. For the first term, a sub 1 is equal to 5. To get the second term, we have the formula a sub 1 plus the common difference. Substitute the value of a sub 1, which is 5, plus the value of the common difference, which is -2. Perform the indicated operation. 5 plus -2, the answer is 3. For the third term, a sub 3, we use the formula a sub 2 plus the common difference, which is -2. Now, substitute the value of a sub 2, which is 3, plus the common difference, which is -2. Perform the indicated operation. 3 plus -2, the answer is 1. Very good. For the fourth term, a sub 4 is equal to a sub 3 plus the common difference, which is -2. Substitute the value of a sub 3, which is 1, plus quantity -2. Perform the indicated operation. 1 plus negative 2, the answer is negative 1. Very good. And lastly, for the fifth term, a sub 5 is equal to a sub 4 plus the common difference, which is negative 2. Substitute the value of a sub 4, which is negative 1, plus copy the common difference, which is negative 2. Perform the indicated operation. Negative 1 plus negative 2, the answer is negative 3. Very good. Now, to get a term, we added the common difference or the constant to the preceding term. So the first 5 terms of the sequence are 5, 3, 1, negative 1, and negative 3.
At this time, find the common difference in an arithmetic sequence whose a sub 2 is equal to 1 and a sub 5 is equal to 7.
At this point, let us try to find the common difference in an arithmetic sequence whose a sub 2 is equal to 1 and a sub 5 is equal to 7. Now, the missing is the common difference. Remember that to find a term, we add the common difference d to the preceding term. For instance, a sub 3 is equal to a sub 2 plus the common difference. This is our equation 1. Another, a sub 4 is equal to a sub 3 plus the common difference, and this is our equation 2. Another is a sub 5 is equal to a sub 4 plus the common difference, and this is our equation 3. Now, substitute a sub 3 in equation 1 to equation 2. So this will become a sub 4 is equal to a sub 3 plus d. Now, if we will try to substitute, a sub 4 is equal to, put a sub 3 in equation 1 to equation 2. So this will become a sub 2 plus d plus d. Now, let us try to simplify. A sub 4 is equal to a sub 2 plus d is equal to 2d. And this will become our equation 4. Next is substitute a sub 4 in equation 4 to equation 3. And this will become a sub 5 is equal to a sub 4 plus d. Next, substitute the a sub 4 from equation 4, which is quantity a sub 2 plus 2d. Then, copy d. Now, simplify the equation. A sub 5 is equal to a sub 2. 2d plus d is equal to positive 3d. And this will become our equation 5. Next is we need to substitute the given in equation 5. A sub 5 is equal to a sub 2 plus 3d. Now, substitute our given, which is a sub 5. A sub 5 is equal to 7. A sub 2 is equal to 1 plus 3d. And this will become our equation 6. For the last part, solve d or the common difference in equation 6. We have 7 is equal to 1 plus 3d. Now, using the addition property of equality, we add negative 1 on both sides. So this will become plus negative 1 and plus negative 1. Next, we need to simplify the equation. Negative 1 plus 7, this will become 6. Then, 1 plus negative 1 is 0, and that will leaves to 3d. Next, multiply both sides by 1/3. As we multiply, 1/3 times 6 is equal to 2. And we can cancel this out. The answer is D. Therefore, the value of our common difference is 2.
For example number 4, find the value of A to make 3A plus 1, 4A, 6A plus 1, an arithmetic sequence.
Find the value of A to make 3A plus 1, 4A, and 6A plus 1 an arithmetic sequence. First, let the first term 3A plus 1 be our A sub 1. Let the second term 4A be our A sub 2. And let our third term 6A plus 1 be our A sub 3. We must again remember that in arithmetic sequence, the common difference D is a term minus the preceding term. Thus, we can say that the common difference D is equal to A sub 2 minus A sub 1. And this is our equation 1. We can also say that the common difference D is equal to third term minus the second term, or A sub 3 minus A sub 2. And this could be our equation 2. Now, if we substitute the given in the equation 1, this will give us common difference is equal to 4A minus quantity 3A plus 1. And this will be our equation 3. Now, if we will substitute the given in equation 2, this will give us D is equal to quantity 6A plus 1 minus 4A. And this will give us our equation 4. Since D is equal to D, we can equate equation 3 and equation 4. And it will give us 4A minus quantity 3A plus 1 in the equation 3. And it is equal to the equation 4, which is quantity 6A plus 1 minus 4A. To simplify this equation, we need to change the signs of the subtrahend 3A plus 1 to negative 3A minus 1. Then we can proceed to addition. Same with the other side of the equation. Copy quantity 6A plus 1. Then, change the sign of the subtrahend to negative 4A. Then we can proceed to addition. Next, we can combine similar terms, 4A and negative 3A, and it will leave us a variable A. Then copy negative 1. On the other side of the equation, the similar terms are 6A and negative 4A, and it will leave us the term 2A. Then copy plus 1. Next is we need to simplify this equation. To eliminate the variable A on the left side of the equation, we will be using the addition property of equality. We need to add the opposite of positive A on both sides, which is negative A, and it will leave us negative 1. Then copy the other side of the equation or simplify, and it will leave us 2A plus negative A. We have the variable A plus 1. Next is we need to eliminate positive 1 on the right side of the equation. Thus, we will be using the addition property of equality and add its opposite, which is negative 1 on both sides of the equation. Now, let us try to simplify. Negative 1 plus negative 1 is equal to negative 2. On the other hand, positive 1 plus negative 1 is 0, thus leaving us the variable A. And now, the value of A is equal to negative 2.
For the sixth example on your module,
I was advised by my physician to walk each day in the morning as a daily exercise. On the first day, I walked 40 meters. On the second and third day, I walked 60 meters and 80 meters respectively, and so on. Which of the following is the distance I walk on the 10th day if I continue the pattern in my daily walk? If we analyze the problem, 40, 60, and 80 meters follows an arithmetic sequence since there is a common difference which is equivalent to 20. Dropping the unit, the given could be written as follows: 40 meters, 60 meters, 80 meters, 100 meters, 120 meters, 140 meters, 160 meters, 180 meters, 200 meters. By continuing this pattern until the 10th term, we have 220 meters as the 10th term. Therefore, on the 10th day, I walk 220 meters.
I hope everything is clear. I know that you are all excited for the next part of our lesson. To ensure that you have the full understanding on the concepts related to arithmetic sequence, it's important that you are able to complete the following statements. Write your answers on your notebook. Number 1, what is the arithmetic sequence? Number 2, how do we get the next terms of an arithmetic sequence? Great job! Now, for the last and most exciting part of our lesson, let us determine how much you have learned from the lesson today. Read and understand each item and choose the letter of your answer. Write it on your notebook. For number 1, which of the following is an arithmetic sequence? Letter A, a sequence in which a term is formed by adding any number to the preceding term. Letter B, a sequence in which there is an equal difference between the consecutive terms. Letter C, a sequence in which a term minus the preceding term is always positive. And letter D, a sequence in which terms follows a pattern. What is your answer? Next, for number 2, which of the following is the common difference in the sequence 0, 4, 8, 12? Letter A, 1. Letter B, 2. Letter C, 3. Letter D, 4. What is your answer? Next, for number 3, which of the following is the first positive term of the arithmetic sequence -11, -8, -5? The choices are A, -4, B, +3, C, -2, and letter D, +1. What is your answer? For number 4, which of the following is the value of P so that the term 7P plus 2, 5P plus 12, 2P minus 1 form an arithmetic sequence? The choices are A, -8, B, -5, C, -13, and D, -23. What is your answer? And lastly, for item number 5, during a free fall rappelling, a skydiver jumps 36 feet, 48 feet, and 60 feet on the first, second, and third fall respectively. If he continues to jump at this pattern, how many feet will he have jumped during the 10th fall? The choices are A, 144 feet, letter B, 156 feet, letter C, 132 feet, and letter D, 140 feet. What is your answer? Now, let us check your answers. For number 1, the answer is very good, letter A. For number 2, what is your answer? Very good, letter D. For number 3, what is your answer? Great job! Letter B. For number 4, what is your answer? Very good! Letter B. And lastly, for number 5, what is your answer? Great job! Letter A. Now let's see. What is your score? Congratulations for doing your best today. And now, that concludes our lesson for today. Always remember, math is fun and exciting. Goodbye, everyone!